All right, so number 2, we have a piecewise function, right? Okay, read it over. What's it asking? And what do they mean? What do they mean how they're drawn? What are they getting at? Well, look at the choices. Open and closed circles, right? For included and non-included points, right? Well, if you take a look at the function, the piecewise function, what x value was in question? 3, right? 3 goes in which one? Which one is 3 included in, the top or the bottom one? The top, because of that equal to sign, right? Okay? So for the closed circle, you'll put 3 in the top, and that'll be plotted with a closed circle, right? Now, if you were to put 3 in the bottom, does it actually go in the bottom? No, but you put 3 in there and plot it with what kind of circle? The open, yeah, that's all they're after, right? So all you have to do is find the value of 3, right? Notice these are all 3, 3, 3, right? And you need to get the correct output, that's all. So figure out which one is going to have your closed circle. What do you do? What do you do with the 3? To what? For which one? The top one. Everybody do that now. G of 3 equals what? Right. So this will be a complement. You quiet down. Right. Remember, if I tell you to stop talking, it's usually a compliment here. So somebody else tell me, where am I putting my x for this? For the closed circle. Which function does it belong to, the top or the bottom? So which one am I putting it in? So G of 3 equals what? What do I write? 5 times 3, which is what? 15. What are the coordinates of that point? What comma what? 3 comma 15, right? And that'll be my closed circle, right? Now, how do I find out the coordinates for the open circle? Go to then the other one, right? So now I'll write G of 3. Watch how I write this, though. It's not equal to. See what I mean? Right? Plus 3 squared. Plus 4. What now? 9 plus 4 is 13. What are the coordinates of this point? 3 comma 13, and that's my open circle. What? It doesn't need to. You just need a table. You need to see it on the calculator. Okay, so what's my answer choice here?
4.
Everybody agree it's 4? All right. Okay, let's move on to number 3. Everybody read that over on your own. The physics equation for falling bodies.
It says it's 128 all throughout.
Let me check. You entered it wrong then. So this equation here models something falling to the ground, right?
Yeah.
Like if you push one of your buddies off the roof, okay? You can tell exactly what height he is at any given time, right? What does the H stand for, everybody? Huh? Height above the ground, right? And what's the T stand for? In seconds. And when, what is it, a ball? So when the ball hits the ground, what is the height? 0, right? Okay? So they want us to graph this. You guys probably should all have a calculator, be the quickest way, right? Run up and grab a calculator, and we'll make a table of values. So T and h, oops, h of t. Keep watching as we do it. Now, when you put it in there and you're making a table of values, look at the graph I gave you here. What's the first value we should have for t? 0, right? And then what? And by the way, Tegan, this is going to work a lot like what you're doing.
It's not working.
And 1, 2, 3, 4, and 5, right? So now just make a table of values on your calculator. All right, so if you're not sure how to enter this, follow along. This over here. Now you can't use t in this, right? So you're going to use x. So it's negative 16 x squared plus 64x plus 60. All right? I'm not even worried about having the whole thing in there. This is just like the one you're working on, by the way. Okay? So what do I need here? To plot the points? Huh?
The table.
Table. So menu. Which part? Where you entered it? Up here? You know what went wrong, or? Yeah, you're using X, right? Okay. Just make sure you have it typed in right, just like it is on the page. Okay? All right, so let's go to menu, table, split screen table. So I do want 0, right? Okay? Ah, there it does that thing again. No, I don't know why it does that. Never mind. So now just copy those into the table that you're going to do in your book. Okay? Don't copy mine, you copy it right off of your calculator, okay? So it's 0, 60, 108, 124, 108 again, and then 60, and negative 20. Huh. What about that negative 20 there? What do these numbers represent in the right-hand column? The height of the ball above the ground, right? And over here is the time. What about this negative 20? What does that mean?
So between 4 and 5 seconds or something like that?
Yeah, but I mean, do we even consider this? Negative 20 height? What does that actually mean? It's under the ground by 20 feet, right? And the calculator doesn't know about t when it graphs x.
That just solved all of my problems.
All right then. Wonderful. Okay, so we're not going to, obviously, the ball's not going to go 20 feet underground, right? So remember, it's a real life problem. We're only working in the first quadrant, everything positive, right? So now just go plot your points. Some of them you have to estimate, right? So 0, 60, 1, 108, about there. 2 is 124. Okay. 3 is 108. And 4 is back down to 60. And then somewhere before you get to 5, it's going to be at 0 there. It's hard to say. Graphs look about like that. Anybody have any issues so far? Okay. Let's go answer the follow-up. Read the follow-up. This is something we've done 5 million or so times. What do they want you to do here?
So we don't place
Determine
outside.
But it doesn't make sense, right? Remember, in a real-life problem situation when you're modeling, you're always like positive time, positive distances, right? First quadrant, okay? So somewhere before 5 seconds, this thing hits the ground. So what do they want us to do?
Determine the average rate.
Please tell me you know how to do average rate of change, right? Remember, f of b minus f of a all over b minus a, right? That's like the general, but we're not going to use f. We're using what? H of. And what are the a and b in this case? From when to when? When he released the ball. So what time was that? Huh? That's at t equals what? When he released the ball. 0, right? Until it's what? Okay. Now look at your graph. What is the t value for the maximum height? The t, the time. So that's the maximum height is right here. That's the 2. That's t equals 2. That is the maximum height. But we're looking for this interval here. Remember? This is my A to B for this thing. Right? A to B. And this is my f of A to f of B. Okay? So instead of f of anything, it's going to be h of what? H of 2 minus h of 0 all over what? Okay, h of 2 and h of 0 should be easy. Did you not just make a table? Look at your table. What's h of 2? All right, go ahead and plug all that in now, okay? What's h of 0? All over, well, that's just 2, yeah? Go ahead and finish this out, you guys. Go ahead. Tell me what the average rate of change is. Let's see.
Yeah. Equals 32.
32 what? Yep, you got to see, that's what you should have in there. So that's 64 over 2, which is 32 feet per second. Okay? Well, this part's new, right? The only thing new really is using your calculator to get a table of values for the quadratic. Right? We graph things, x and y, and we've done average rate of change a number of times. Okay? So let's go to the other side. Ah, yes, another piecewise. We want us to graph that one. So we're going to have to think about what kind of circles in this one. Open and closed, right? Okay. So what's the value, the x value that the two functions share?
Zero.
Yeah, they'll kind of share 0, right? The 0 really belongs to which one of them?
The bottom one.
The bottom one. So that one will get the closed circle, right? Will you, in your table, will you put 0 into the top equation? Just to see where the open circle goes, right? With the closed circle, right? So, okay. Do you remember how to put this in your calculator as a piecewise function? And you don't have, I mean, you can do them each one at a time if you want it, right? Well, let's just do x and then h of x. So, like for h of x, what kind of values am I going to be putting in there? What does x less than 0 mean? What's another way to say numbers less than 0? They are what? Negative, right? So maybe the top function will do negative, I don't know, 3, 2, negative 1. Should I do 0?
Yeah.
Yeah, but I'll kind of put parentheses around that, right, just to, okay? So that'll be my top function. And how about for the bottom? What should I use? Huh?
5 to 0, 0 to 5.
0 to 5, right? And I'm going to stop at what? Because that's what they said, right? So 0, 1, 2, 3, 4, 5. And get some value, so that's my second one, right? All right, let's put that into the calculator. Let me get back over to this side here. Well, let's get rid of the table for now. Menu, to table, remove table. Okay. So let's do tab. Let's go up. I hit Control Clear, and it'll make that go away. Does anybody remember where to find the piecewise thingy? You see the button here next to the right of the 9? Right? So hit that button. Should be one that, well, mine's highlighted there. See what it is? Remember doing that? Yep. Okay. So put. Well, when I went in, when I pushed that, it was a little like already kind of selected. Yours might not be. I don't know. But it's the one that looks like that. Huh?
Mine's all messed up.
All right. Push the tab button again, the entry. Press that button next to the 9. Exactly. Okay.
How do you use the greater than?
Control equal. Right? All right, so let's get some stuff in here. Come on. What the what? Yeah, I know. I'm going to clear all this out there. 1, 4, enter. Yeah, that. Oh, I know what it did. All right. 2x minus 3. 2x minus 3. Move into that guy. And we want for x control equals, right? And we're less than. 0. Down. The other one. X squared minus 4x. Minus 5. And that is from 0. Control equals, and they want less than or equal to. X. Control equals less than, they want to include it, right? Yep. Less than or equal to 5. You got that? No? You will, right? You got it. Okay. So we have an idea what this will look like. I'm going to move all that stuff out of there. I'm just going to delete that. I don't need to see it all, right? But this looks like the first part of my function. Now remember, they don't do the open and close circles on this thing. Okay? And then the other one's quadratic, right? So it's like a parabola. So let's go make our table of values, right? So menu, table. Remember, I wanted to start at -3, yeah? Okay? All right, let's fill that out. 3, so we get -9, -7, -5. Now be careful. They're not putting this one in here, right? In the table, what do you have for 0? You don't.
Well, it says -5 in the table.
Right, because it does. Because it's using, because it knows the way you told it, right? It's using the bottom one. So the -5 they have in here in the calculator is there, right? So how do I really quick get a value for 0 in the top one? What's just in your head? What's 2 times 0?
0.
-3.
-3.
Okay, right? So the calculator won't give you that because you told it doesn't belong in that one, right? So you just have to kind of do it. Okay? And just copy the rest of the values from your table, not mine, look at yours, right?
Yes, 42.
0, -5, 1, -8, get all switched up here, 2, -9, -8, -5, and 0. And you probably want to use a straight edge if you don't have one. Try and draw it as straight as you can. Okay? So, 1, 2, 3, 1, 2, 3, 4, 6, 7, 8, -9, 2, -7, -1, -5. Now my 0, -3, what kind of circle am I putting here? Open circle, right? Now this one will have an arrow at the end of it, right? Won't it? Because it's all the x's less than 0, right? Like not in between anything, yeah? So that one keeps on going. Will our second one have any arrows on it?
No.
Because it starts at 0 and stops at x of 5, right? So we'll plot those points. So 0, 3. Now that's our closed circle, right? At that 0, -5, yeah? And then 1, 7, 8. 2, -9. 3, -8. 4, oops, 4, -5. And then 5, 0. Do not make a V out of it. No arrows on that one, right? Because it said between 0 and 5, okay? Remember, you got to get the open and closed circle right. You lose points, okay? You guys shouldn't be looking up here to copy. Just go right off of your table of values on your own calculator, all right? Because this isn't going to be up here on the readings exam. You plot them yourself. Remember now, the 0 that goes in 2x - 3 will not show up in your calculator table because you entered it to be not included in there, right? So you have to put that one in on your own to know where the open circle is. Okay? Any questions on this one? Okay, take a second and finish that up and read over the next one. Is it square? So what I need everyone to do is right now, before anybody answers another question, read number 5. Read number 5. I'm not going to read it for you. Okay, it's about a garden. Amy, describe this garden. What can you tell me about the garden, Amy? Is it a circular garden? Is it shaped like a pentagon? It says rectangular, yeah. Okay. Hannah, what's he doing to the garden? Okay. Well, what's he going to do to it then? We'll read the problem.
You will use 36 feet of fence to enclose.
Okay. All right, so he's putting fence around it, right? 3 sides of it. Okay. What else does it tell us about this garden, Tammy? What else do the words tell us about the garden? We've got that it's rectangular. We got he's using 36 feet of fence.
It can be modeled by the function f of w equals
What can be modeled by the function? It?
the area
It says, okay, the area of it, yes.
f of w equals w times 36.
And what is W? The width of the garden, right? So we can make the garden wider or narrower, yeah? Hey, this function here, is this gonna be a quadratic function? Why not? What makes a function quadratic? Look back to 8.1. What makes it quadratic? Just flip back, everybody. 8.1. What's the highest exponent?
2.
Okay, so it has something squared, and then it's quadratic, pretty much, right?
No.
Is this, huh?
No.
That's linear. So is this a quadratic function?
No.
Why not? Oh, okay. What would happen if I distribute this W through? So it is quadratic, isn't it? Because I'd get 36W minus 2W squared, right? So it will make a parabola. Okay. So what do they want us to do with this equation? But they leave it as a mystery, don't they? They just say, here's the stuff. They don't say what they want you to do with it. Or do they? Grab it, right? Hey, I bet you it's going to work about like we did it before. You got your calculator? You guess? Good guess. So what are you going to put in your calculator? That thing, right? Well, yeah, you can do it that way. You can just go up to it and hit delete or, clear it out. Yeah, all right, so we're going to make a table. No, X is what, yeah, you have to use X. So just like whatever they're giving you, the calculator only knows the graph of X.
So I have to equals, I can use X.
Yeah.
X equals.
Well, you're not going to type in F, but it already has the F of X thing. Yeah, right. You're just going to use an X instead of their W. All right. In your table of values, what are you going to go from? From what to what? Look at your axis. 0 to 20. I don't know if I want to put all of those in the table. How can I shorten my table instead of having a table with 20 points in it?
Yeah, it's not linear.
Huh? It's not letting you what? What?
It's not what you do.
Okay. So W, F of W. I don't want to go 0, 1, 2, 3, 4, 5, 6 to 20. What could I do to shorten that up?
2, 4, 6.
Huh?
2, 4.
Oh, by twos, maybe, yeah? Table by twos. But I always start with 0, don't I? So 0, 2, 4, 6, 8, 10, 12, 14, 16. I should have made it smaller. Squeeze them in there. 0, 2, 4, 6, 10, 12, 16, 18, 20. All right, throw that in your calculator and get your X values, or W values, or H or F values. Anybody having trouble getting in their calculator, getting the table now? You are? What's the problem? Invalid input. Oh, yeah, guys, I remember what it is. For some reason, everybody listen. This is W times that, everybody look up here. W times that thing in parentheses. For some reason the calculator makes you put like W, put a times in there and then parentheses. So it knows you're multiplying there. Just one of the little quirks of the thing. And that should fix your invalid entry thing. You got a good net? Huh? Well, it's because of your window. If you open up your window, you get.
2W, you have to 2X.
Yeah. Where is the WX, right? Yeah. All right, so tab, oh, no. Here, x times parentheses 36 minus 2x. All right, so I'm going to go 0 to 20. Whoops.
Get that thing.
What thing? The table?
Yeah.
Menu. Table. You love it when you figure things out. Uh-huh. So 0, 64.
Not right. It does not look right. It does not look right.
Mine's not.
Well, your graph's probably only going to show like where it goes up.
But I think I have the table.
I just clicked the wrong one.
You have 0 and 64 or 0 and 2?
Oh, oh.
Okay. Check what you typed into the equation.
Maybe I just do X for all of them instead of like W.
You have to, yes. Yeah.
This is taking.
The calculator doesn't know W's. 90 and 112.
Why is it not working?
Okay, now I got it. 162 and 9.
I'm not going to write 162. I want the coordinates. What comma what? 9 comma 162, right? What does that mean? What does the 9 represent in this problem?
That's the biggest width.
That's the width of 9, and what is
the area?
in the area? And what is,
the biggest it can get.
right? That vertex is a max or a min?
Max.
A max, right? So what does this vertex mean?
It's the biggest, 162 square feet is the maximum.
So, yeah, the max area of the garden is 162 square feet at what?
9.
At a width of 9, right? So the max area of the garden is 162 square feet at a width of 9 feet. Okay? You see how we answered that in terms of the problem, right?
Yeah.
You can't just, like if you just said it has a max of 162 at 9, will you get any credit for answering that? Right, because it said in context of the problem. Do you understand the difference, huh? I don't know. I think it's Mr. Kelly.